A testing lab wishes to test 2 experimental brands of outdoor paint to see how long each will last before fading. The testing lab makes 6 gallons of each paint to test. Since different chemical agents are added to each group and only 6 cans are involved, these 2 groups constitute 2 small populations. The results in months are shown. Find the mean of each group. The mean for brand A is 35 months, but we note also that the mean for brand B is 35 months. So we can see then that measures of central tendency are not always ideal in contrasting 2 data sets. Looking at a graphical display of the data sets, we can see that the data values for brand B are grouped quite a bit more tightly. So what we need are some measures that provide us with a way to describe how the data values are spread out. These are called measures of variation. The first measure of variation that we'll talk about is the range. The range is the highest value minus the lowest value. We use the symbol capital R for the range. So looking then at the maximum and minimum values for these 2 data sets, we can see that for brand A, the maximum value is 60 and the minimum value is 10. So the range would be 50 months. For brand B, the maximum value is 45 and the minimum value is 25. So the range for brand B would be 20 months. In this case, the range exhibits this tighter distribution of the data values that we talked about. But the weakness of the range is that a few extreme data values can cause a dramatic increase. For instance, if there were one more data value in this data set, and that data value was 100, then the range for group B would be 75 months. The range for group A was 50 months. And now this extreme value has distorted this measure of variation for brand B. So while the range can sometimes effectively describe how spread out the data values are in a data set, it is not always ideal.